Problems, what we're going to be doing is the reverse. We're going to start by taking a angle that is in radians and converting it into degrees, but we're going to do the same thing that we did before, which is use a piece of information to convert one to the other. So what we're going to start out with is our angle here is pi over 9. Now, they don't give us the units, and if they don't give you units for an angle, it's understood to be in radians. However, they did kind of tell you in the problem, even though they didn't write it right next to the angle. So we're going to go ahead and add that in, and then we're going to multiply by a fraction so that we can get rid of the radians. So I need to be able to somehow relate radians to what we want, which is degrees. Well, we know that there are pi radians is the same thing as 180 degrees. Now, because I want to get rid of the radians, I'm going to put the radians on the bottom. So we've got pi radians. That will go on the bottom. And we'll put the 180 degrees on top, and let's see how that helps us. So the radians on top and the radians on the bottom cancel out. Also, what's going to cancel out is we've got a pi on top and a pi on the bottom. Notice that we will now have a degree symbol that we're going to pick up. The question is, how do we get the value? Well, on top, the pi canceled out, so all we have on top, if we look at this, because the pi canceled out, is what's left on top is the 180 and the degree symbol. So on top, I've got 180 degrees. And on bottom, notice the pi also canceled and the radians canceled, but also on the bottom, I've got a 9. So the only thing that's left on my denominator is just the 9. So let's go ahead and put over, over 9. So we've got 180 degrees divided by 9. Which, let's see, will end up being 20 degrees. And that's our final answer. And that's our final answer for turning our angle, which was pi over 9, into degrees. Let's try another one. Let's try the next angle, which is 7 pi over 6. And I'm going to again put that this is understood to be in radians, so I don't forget what I'm doing. I'm going to multiply by a factor here. Again, I'm trying to get rid of the radians, so I'm going to put the radians on the bottom. So we'll do our pi radians. And how many degrees are in pi radians? Well, that's 180 degrees. And remember that we're doing this so that the radians on top and the radians on the bottom cancel. However, also the pi on top and the pi on the bottom cancel. The question is, what do we have left on top? Well, on top, let's see, we've got, on top we've got the 7 times 180 degrees. So the question becomes, what is 7 times 180? This gets us 1,260 degrees. And don't forget, we can't forget about the denominator. What do we have on the bottom here? On the bottom, we just have a 6 because the pi canceled out and the radians canceled out. So we've got a 6 on the bottom. So let's see, we've got 1,260 divided by 6, which will give us 210 degrees. Let's try another problem. In this next one, we have an angle of, let's see, -6 pi. And of course, that's going to be in radians because we don't see any units. And again, we're going to multiply by a factor. And we have been using pi radians equals 180 degrees. You could always use 2 pi radians equals 360 degrees. I just tend to like to use the one with the smaller numbers just to make my life a little easier. So I'm going to continue doing that. So to get the radians to cancel, we'll put the pi radians on the bottom. And that means 180 degrees needs to go on top. Notice, once again, the radians cancel out on the top and the bottom, as well as the pi's cancel out on the top and the bottom. So let's see what's going on then. Well, then that means on top, we have, let's see, a negative 6 times 180. So the question becomes, what is negative 6 times 180? And that's going to be 1,080. Again, that's negative 1,080, and that's in degrees. Now, notice everything that was on the denominator canceled out, so there is no denominator, or if you were going to write a denominator, it would merely be a 1. Well, dividing anything by 1 would just stay the same and would leave us with a negative 1080 degrees, and that's it. In these next few problems, we're going to again go back to converting degrees to radians. So as a reminder, the way we convert degrees into radians is we'll start out with our degrees, which on this one was 74 degrees, and we'll multiply by a fraction in which we relate radians and degrees. We want to relate radians and degrees. We'll do it the same way we've been doing, which is that there are pi radians, and you can shorten that to rad if you need to. Pi radians is the same thing as 180 degrees. It's just this time we're going to put the degrees on the bottom so that the degrees cancel out. So we'll put the 180 degrees on the bottom and the pi radians on top. And what that will do is then cancel out the degrees and leave our final answer in radians. So let's see what this does for us. On top, what we'll have, let's see, is we've got the 74 times the pi. So on top, we'll have 74 pi. And we do have our radians there. We can put them off to the side too. It doesn't matter if it is written on top or off to the side. And on the bottom, let's see what we have. We have the 180 on the bottom. Remember the degrees canceled? So this is what we've got so far. Now, normally, if they said to leave it as a fraction, we would leave it just as is, but we would want to reduce it first. Here, we don't need to reduce it if they just want us to turn it into a decimal, which is what they want us to do. So on this one, let's notice that they want us to convert it and round it to the nearest thousandths, which means we don't need to reduce it, we just need to convert it into a decimal. So let's see how we do that. Now, when you use your calculator like we did below, notice that we want to use the pi button, not 3.14 when we go ahead and plug this in. Now, I just did this on a regular scientific calculator, which you are allowed to have on all tests. You won't always be allowed to have a graphing calculator per se, but you will be always allowed to have a scientific calculator. And all scientific calculators have a pi button on them. So when you use your calculator, what we got, if we rounded to the nearest thousandths, which is where that 9 is, what the 1 tells us after it is that we're going to stay the same. So our final answer in radians is 1.29 radians. And again, this is only done this way if they want us to turn it into a decimal and they don't say anything about reducing it as a fraction. Let's try another one. In this next one, we have 174 degrees. And this is the first time we're going to have this is 50 minutes. So the first thing that we should be focusing in on is how to convert our 50 minutes into degrees so that we're not dealing with both degrees and minutes, but we're just going to be dealing with degrees. Well, remember, let's see how we do that. Well, to turn the 50 minutes into degrees, we have to remember how many minutes are in a degree. Well, remember from way back when is that there is 60 minutes in 1 degree. So we're going to use that piece of information. Because we're trying to get the minutes to cancel out, that's what'll go on the bottom, the 60 minutes, which is equivalent to 1 degree. So what happens there is the minutes will cancel and we'll end up with our final answer being in degrees. So what do we have on top? On top, let's see, we've got a 50 times 1, which is 50. And on the bottom, we've got divided by. On the bottom, all we have is that 60. So we need to do the 50 divided by 60. And again, remembering that our units here are in degrees. So let's see, what is 50 divided by 60? So 50 divided by 60 gets us 0.83, and that's in degrees. So what this means is our 174 degrees in 50 minutes, that 50 minutes got converted to this decimal, the 0.83. So our 50 minutes got converted to the 0.83. So now what that means is I can rewrite our angle as, let's see, 174 was the beginning, and we just came up with the 0.83 as our decimal part of our degree from turning the minutes into degrees. Now that our entire angle is in degrees, now we can worry about converting it into radians. So now we can take our 174.83 degrees and convert it into radians by multiplying by just the same thing that we did before. Remember, we put the 180 degrees on the bottom and the pi radians on top. And what will happen is the degrees will cancel out and our final answer will be in radians. So let's see what we end up with. On top, we've got our 174.83 pi, our 174.83 pi, and don't forget your radians. And on the bottom, we have divided by our 180 that was down there. That has not changed. Now we just need to plug this into our calculator. Let's see what happens. In this next group of problems,